So yes, that's what we did yesterday. Okay. And this is the comments, the steps, right? This is the typical steps. Okay, this steps I saw from student. Okay, this typical step I saw from student is that when you multiply two numbers and it's negative, but then each one is negative, right? We know that's false. We know that's false, right? So you have to have a logical context in that the work you present must have a logical context. So what are the logical foundations here? What are the logical foundations here? The logical foundations actually is, well, first of all, we have the 6 mathematical principles. And secondly, today I want to talk to you because we didn't go over this, right? It's called truth table. Truth table. Okay, so before we start this, we're going to take a look at what is a truth table. Okay. I'm asking you to go back to the notes on page number 2. Okay, so let's start with truth table. Truth table. Okay, are you guys there? Okay, so what is truth table? First of all, we explained that any statement is either true or false, right? Any statement is either true or false. So yeah, so first of all, we start with a statement. Okay, so we have a statement we call A. Okay, and we have another statement. Another statement. We call it B. What are statements? Statements in our everyday life is just you make a sentence, you make a statement, okay? But statement in mathematics often is a shorthanded expression. It's a shorthanded expression. For example, you can say, you can make a statement saying, the domain of sine x is all real numbers. That is a statement. Okay, that is a statement. You can also say the range of sine is all real numbers, right? So a statement you say can be judged either as true or false. So we have one statement and we have another statement. Okay, so to make it condensed, so we just call them statements. A or B. We have two statements. Okay. Now, A and B is a statement. A and B is going to be a statement. What does it mean? So we're making composite statement. Okay, you basically put two statements together, right? We put two statements together and make one statement. So one statement and another statement. For example, I can say, the first statement I would say, A, the domain of sine is all real numbers. Okay. My second statement, B, I would say the range of sine is all real numbers. Right? Okay. But when I say A and B, what does that mean? I'm saying the domain of sign is all real numbers and the range of sign is all real numbers. Do you guys follow me? So that's two statements. I'm going to write it down for you. Okay, examples. Okay, just examples. Statement A, I say the domain of sign is all real numbers. Okay, that's one statement. You can judge it right or wrong, right? B, I say the range of sign is all real numbers. Okay, so looking at these two statements, we will be able to know, we will be able to judge, right? So which one is true, which one is false?
A is true.
A is true. How about B?
It's false because it's -1 to 1.
That's right, B is false. A is a true statement, B is a false statement. Is it possible we have a true statement for B? Sure. So A could be true or false, B could be true or false. Okay. And these are examples. Okay, so I can make another pair. I can make another pair. Okay. The range of sign is, so this is my other statement. B is also a statement. Okay, I'm using completely mathematical notation to say what? Okay, so this is two statements. One is true, one is false, and this is another statement. One is true, and the other one is also true. Both are true. Do I have other examples? Of course, you can have all kinds of cases, right? Okay, so the domain of tangent x is all real numbers. And for B, I'm going to say the same one. Right, that's another two statements, right? So you can keep this list going on, right? Two statements. But when we put these two statements together, it makes another statement. And we have to judge if the new statement is true or false. Okay? And another scenario is we create another statement, which is A or B. A or B. So we need to understand what, now we have four statements. We have four statements. So what are the four statements? A is a statement, B is a statement, A and B is a statement, and A or B is another statement. So we have four statements. Do you follow me? And the situation could get a little bit more complicated. The situation could get a little bit more complicated because A could be true or false, B could be true or false. When you combine them, you have four cases. You have four cases. Okay, so we're going to start with So you understand these are statements. Okay, so I'm going to give you, before we go to the truth table, okay, I want to give you another two statement. Okay, these two statements will be closer to our life. Okay, the first statement, okay, the first statement and the second statement. Okay, the first statement is this. Okay, suppose the topics of discussion is to sell a car or not. So the two person involved is me, is me and my husband. Okay, is my, the topic is about selling the car or not selling the car. Selling a car or not selling a car. This is be a good example. I use this example for quite a long time, but I kind of want to rephrase it. Okay. How about we use the names on the title? Okay, names on the title. Okay, so we have this car. Okay, we have this car, and our car is a Honda Accord. Okay, Honda Accord 2001. We have a 2001 Honda Accord. Okay, we're talking about its title, the title. On the title is the title is my name and my husband's name. Okay, LW and CW. Okay, that's what's on title. Okay, the title of the car. Okay, and the topics of discussion is that the two of us, decide, are we going to sell the car? We're not going to sell the car. And that's how the title is written, right? You guys understand this, do you? Well, you receive a check, right? Your name and your mom's name, right? Anyway, so that's what's on the title. One statement, I wish to sell the car. Okay. Sell the car. Okay. And my husband, he said he will sell the car. Okay. Then when I say okay, I think I make it more complicated. Okay. I want to sell the car, and he does not want to sell the car. I want to create a situation. Okay, it's about selling the car. Okay, it's about selling the car. Okay, there's a couple situations. So if A, so the when we say, so A could be true or false, right? As I'm saying, I'm going to sell the car. If I say true means selling the car. Okay, and false means not selling the car. I'm not going to address selling the car. I'm not going to address just 2%. Okay, we're making statements. This is better. This is simpler. Okay. So if I say the statement A is true, that means I want to sell the car. If the statement A is false, that means I don't want to sell the car. Does that make sense? Does everybody understand the scenario? Person A is me and person B is my husband. And the title is my name and his name. Is that clear? There. Okay. Person A, that's me, and person B, that's him, right? A is me and B is him. Do you follow me? Now, I want to sell the car and he wants to sell the car. So we both sign the title, we sell the car, right? Because the title is on end. Okay, the title is on end. Does everybody follow me? So our car will be sold. We'll have no car. Okay, so true and true is true. You follow me? Yes, does everybody follow me? Now, I want to sell the car and he doesn't want to sell the car. Not selling the car. Yes? If he doesn't agree to sell the car, can I sell the car? He's not going to sign it, right? Because the title is on my name and his name. So true and false is what? False.
False.
That's right. Now, I don't want to sell the car because we're not going to have any car. And he wants to sell the car. He wants to buy Tesla. No, we don't have money to buy Tesla. So false and true is what? False. Right? Because I don't agree to sell the car. One more row. Do you guys follow me? I'm using this example because it's closer to our life. It's closer to our life. Okay, so now I said, we're not going to sell the car. And he said, we're not going to sell the car. Okay, so F false and false is what? False. This is a truth table number 1. Okay, in other words, when you have two statements, when two statements are both true, true and true is true. True and false is false. Yeah? Because it's and. And means both must be true to make it true. Yeah? Is that pretty common sense? Okay. False and true is false. Okay, we'll come back to our statement, okay? And false is false. Got it? Okay. So now the scenario has changed. Okay, instead of and, we have or. Instead of and, we have or. So the title this time, okay, the title in the first case, the title is my name and his name. Now, our new title is my name or his name. You follow me? And this case, let's see what happens. Okay, it's still the same story. Okay, it's about selling the car or not. He wants to sell the car. Well, I want to sell the car. He wants to sell the car. So he, well, I or him, the or, we both agree to sell the car. Therefore, the car will be what? Sold. Right? Now, I want to sell the car. He doesn't. Could I still sell the car?
Yeah.
It's not going to be very pleasant in the household, right? Okay, as you can imagine. But I can still do it, can I? Yeah, so true or false is what? True.
True.
We're going to have a big fight, right? Can you imagine? We're just talking about this is just a joke, right? It's just a joke, but it's closer to our life, isn't it? It's closer to our life. It's just related to title, right? You have a title to your car, you have a title to your house in the future, and so on and so forth. Then I don't want to sell the car, and he wants to sell the car. So false or true is what? True. He can still do it, right? I don't agree, he can still do it anyway. The last case scenario, I don't want to sell the car. He doesn't want to sell the car. So false or false is what? False. So now, these two tables are the truth table I referred to. Two basic truth tables. Okay. The key words here are and or. And or. You can see it makes a big difference, isn't it? So when you work through your math questions, the word and or have the same meaning in mathematics as they are in the real world. Do you follow me? And especially in the legal area. If you see a legal document, right? If you see a legal document, they use the word and or you use the word or, they actually mean the same thing. The same truth table would apply. Okay. I used to use the example in real life, which is about the use of a car seat. Okay. When my children were younger, now they're adults, so I haven't used those examples for a long time. But it's very similar. Okay, I don't know what is the legal requirement today anymore, but do you guys want to have a discussion on that? Do you think that might be interesting? We can find out from the internet. Are you ready for it? Yeah, why not? Okay, car seat rules. Car seat law, right? I found a car seat law. Okay, I will copy and paste. Children under age 4 must be properly secured in a child restraint system. Okay, let me see if they have and or for us to discuss. Okay, so this is the, I just copied this from AAA of motor law. Okay, child passenger safety. You guys see this, right? Children under age 4 must be properly secured in a child restraint system in the rear seat. If possible, they must then ride in a booster seat until they turn 8, weigh more than 80 pounds, or hear the word or, are taller than 4 feet 9 inches. Violation of the child restraint law is a standard offense. So now let's have a discussion about this. Okay, the first sentence, there's no argument, right? The child is under age of 4, you have to be in the car seat or some kind of, restraint. Let's look at the second piece. Let's look at the second piece. They must then ride in a booster seat until they turn 8. Weigh more than 80 pounds. What does that mean? What does that mean? They must.
It could be either 8 or be 80 pounds. So it's or.
They either, so what? They must ride in a booster seat until they turn 8. Right? There's no words here. It sounds like it's going to be an end, right? Right? Does this mean an end? You have to turn 8. But not every child to turn 8 is more than 80 pounds, right? So is this requirement and or? Actually, it was not explicitly written, isn't it? What do you think? Is it and or?
I think it's or.
You think it's or?
I think it's or.
You think it's or? Okay. So if you think these two parts are or, the reason you think it's or because this is or?
No, I just think it makes more sense. I don't know.
You see this, suppose it's an or.
Mm.
Suppose it's an or. Okay, because it looks like it's going to be an or. I think that the law, the interpretation, obviously this person didn't study logic or something. Okay, or maybe it's just they use the common sense. But anyway, usually the legal statements are very, very clear, and or they should be. Okay, otherwise they're going to be loopholes, right? They're going to be loopholes. So there will be 3 cases, right? They must ride in booster seat until they turn 8. Okay, so now I'm going to ask you some scenario. Okay, suppose a child is 9. Okay, but he's less than 80 pounds and shorter than 4 feet 9 inches.
He could still, or he doesn't have to. I mean, he doesn't have to sit.
Don't have to?
No.
I see.
Because it's
everybody
or,
agree with that?
So I feel like since or, he only has to have one of the requirements.
if these cases is or, right? I think you got it. If these three conditions is or, right? Then if one of them is true, then the child doesn't have to be in the car seat, right? Suppose a child is 5 and he's already more than 80 pounds. Does he have to ride in the car seat or booster seat?
If he's more than 80 pounds, no.
This child is more than 80 pounds, but he's only 5.
Well, that depends if it's actually or and.
That's right. You can see and or is very important, right? Now the question is, are these and or? So is this and or?
I believe it's or as well.
You believe it's or.
I believe it's or.
If you believe it's or, and this child is, if this is or, okay, suppose this is or, okay, and this child is 80 pounds or 81 pounds, but 5-year-old and less than 4 feet 9 inches. Does he need to be in the car seat?
No.
If these were or, you're right. The child doesn't have to be in the car seat, even though he was only 5. Okay, but if this is and, then he has to be in a booster, right? He has to be in a booster. You can see.
Yeah.
So yeah. So you can see that from this, we're not going to spend time here forever. It's just the word or and to be there or not makes a big difference, isn't it? All right, so that's what we understand. We're not going to discuss about this law any further. So let's go back to our earlier examples. Let's go back to our earlier examples. Okay. This is A, this is B. Okay. So what do you think? A and B, we know A and B is a new statement, right? A and B is a new statement. If A is the domain of sine x is all real numbers, B is the range of sine x is all real numbers, what is the truth? Is it true or false for A and B?
False.
That's right. How about A or B?
It would be true.
A.
Hmm?
A would be true and then B would be
It's
false.
true, that's right. This composite will be true. Very good, you got it. How about everybody else? Now, look at the second one. The second scenario, okay? It's still about A. Okay, the second scenario. A and B. Is it true or false?
True.
Very good, because both are true, right? How about A or B?
It would also be true.
That's right. Excellent. You got logic in you. Does everybody follow? Now, for the last one, I'm I don't think we need to go over the last one, right? Do we need to go over the last one? We don't need to. Okay, you both are false, that's false, right? In this case, both are true. I don't think we need to go through any further statement. Now, with truth table behind us, I think we're ready to attack 10A. Okay, yesterday we already have a discussion. We already had a discussion, right? When we multiply two numbers, right? How we see this, how you math professor, your math nerdy professor read this, right? If this is true, then this is true, and that statement itself is false. You follow me? So we are in a little bit more complicated situation. We're in a little bit more complicated situation. So is everybody with us? Do you want, because we talk about this at the end of the class, I want to make sure everybody got this. Yeah? Okay, so now let's go back to see basic 10A number 1. The perspective. The perspective. When you see this statement like this, what kind of statement is it? It's an if statement, okay? It's an if statement. And this if statement basically is telling you the product of two numbers is negative. Do you follow me? Because we don't know what x is, and we don't know x plus 2 is then. We don't know what x is, therefore we don't know what is x minus 3. So because we don't know x, we don't know either one in terms of value or in terms of sign. Do you follow me? So the perspective, when I see this product, I see this. You follow me? So in your thought, you'll be thinking, okay, this is a product of two numbers. And we are told the product of these two numbers is negative. Okay, so let's write it in word. The product of two numbers is negative. That's what's given. That's a given. It's like a condition given. Okay. Then what is it solving for means? Under this if statement, we need to figure out all the possible values for x under the circumstances. That's the meaning. But two numbers involved, right? So when we know when we multiply two numbers and the product is negative, it could be one is false, or one is positive, the other one is negative, or vice versa. So the two numbers cannot be of the same sign, right? If one is positive, the other one must be negative. If one is negative, the other one must be positive. Do you guys follow me? That's principle number 6, isn't it? That's principle number 6. There are many different methods to attack this kind of question. Okay, I'm gonna show you I would say the simplest version of this. Okay, there are many different methods to do this. Okay, when I was in school, I learned different methods. But when I started teaching, the textbook told me to teach another method. And the method I'm going to present it to you is more of an illustration and application of principle number 6. Okay, so this part, I'm going to show you the analysis. This part is not the actual work you need to show the professor, but I will give you the final version of how do you show your work. Okay, but mainly I want to give you the idea of how to analyze it. Okay, so this method I'm giving you is no longer available in most of the recent textbooks. It was kind of in the older textbooks, years ago. But I think this illustration would be, I've been using this illustration, and it seemed to be pretty helpful. Okay, so now I see x plus 2 as a number. Okay, x plus 2, we regard x plus 2 as a number, is a number. Can we do that? This number may assume different signs. Depending on the values of x. Depending on the values of x. Do you agree with me? Right? If you think about it, okay, if x equals to 5, then x plus 2 is what? It's positive, right? It's positive, right? If x equals to -10, x plus 2 would be what? It's negative, right? If x equals to -2, what happens? X plus 2 is 0. So you keep trying different numbers to plug in x plus 2. Do you find a pattern as when it is positive, when it is negative? Is my question clear? Is my question clear? Because obviously you can plug in any real number, right? You can plug in any real number. If you see this as a function, right? You see this as a function, right? Input is x, right? Your output is x plus 2. And we're only concerned about the sign, either positive or negative. You guys follow me? You can see this as a function. The question is, when is it positive, when is it negative? Have you found a pattern? Have we found a pattern? Can we find a pattern? Anybody? Everybody?
Any number greater than -2 is positive?
Perfect. Perfect. Do you agree? When x is larger than -2, x plus 2 is a positive. What else? What else have we found?
When x is less than -2, it's negative.
Perfect. Okay. When x is less than -2, x plus 2 is negative. And what else? When x is equals to -2, what happened? X plus 2 is 0. Could I say x plus 2 changes sign at -2? Could I say that? Can I say that? X plus 2 changes sign at -2. Do you agree? Yeah? Okay. How do we say a number is positive? How do we express that? We use greater than 0, right? How do you say a number is negative? Huh?
Less than 0.
Less than 0. Very good. Right? You see, that's the mathematics, right? So when you read the sign, you need to reflect on the meanings. We need to reflect on the meanings. Now, how do you express x plus 2 is positive when you do this? Right? Do you follow me? So when x is larger than -2, x plus 2 is positive. When x is less than -2, we say x plus 2 is negative. When x is -2, x plus 2 is 0. So I claim x plus 2 changes sign at a -2. Do you follow me? I'm doing kind of slowly, but does everybody follow me? Because I really want to get the idea to you. I want to show you the idea is very simple. Do you follow me? You don't have to memorize 5 steps, 10 steps, 3 steps. Now, we understand that I want to give you another perspective as well. We know functions, right? Every function corresponds to a picture, right? What would be the picture for x plus 2? This is the picture. We know that it's a straight line, right? Right? We all know this picture. It's a straight line. Why do I bring this picture? Because I want you to see the visually. I want you to see visually. Okay? Visually, there's a point. What point is it? -2, 0. Sorry. -2, 0. This point. You see, I promise you this function, this class is the major theme is function. For function, it's all about input output, right? For input -2, the output is 0. When input is larger than -2, what happens? When input is larger than -2, what do we get? All of these pieces are positive. Do you guys see that? Positive piece, because it's above x-axis, right? When input is less than -2, they're all negative. Do you follow me? You see, they're all consistent. Okay, and at -2, what happens? Input is -2, the output is 0. So that's why we make the claim that x + 2 changes sign at -2. Do you follow me? You either go upwards, you go downwards, and x + 2 changes sign at -2. Does everybody follow me? Now, so we understand that. Let's see how we express it. Okay, so x + 2 changes sign at -2. How do we express it? Okay, we can express this in a multiple different ways. Okay, one of the ways is just use a number line. I have a number line. This is a number line. Okay, this is a number line. And there's one place the number is -2. Okay, in terms of sign of x + 2, when x is less than -2, it's negative. I'm using negative sign above it. Okay, at -2, it's 0. Beyond -2 is positive. Does everybody follow me? Yeah? So this graph is a shorthand version of what we just discussed. When x is larger than -2, x + 2 is positive. When x is -2, x + 2 is 0. When x is less than -2, x + 2 is negative. Do you follow me? Does everybody follow me? Now, if you think you understand everything so far, okay, let's look at x - 3. Can you tell, can you draw a picture about the sign, the sign of x - 3? You guys understand it, right? So now you start to figure when is x - 3 positive, when is x - 3 negative, and when is x - 3 0. Which one do you want to figure out first? You want to figure out when it is 0 first, isn't it? See, you start to figure out these patterns because it's easy to figure out when x minus 3 is 0, yeah? Now, can you draw a similar picture for x minus 3? Number line. I want to be relative to that one. Okay, 0 is somewhere in between, right? So what will be the sign of x minus 3 when x is less than -3? Do you guys follow me? So what sign would you put there? Negative, right? Yeah? Oh, I'm sorry, +3. I'm sorry, I made a mistake, +3. Okay? At +3 is 0, right? Beyond -3, what would it be? Positive. Do you follow me? Does everybody follow me? And of course, you can also draw the line from the function's perspective, but we don't need to do that anymore, do we? We don't need to do that anymore. All right. We know the sign distribution of x plus 2, and we also know the sign distribution of x minus 3. How about the sign of the product? How about the sign of the product? How about the sign of the product? Number line again. Right? Number line again. And here's -2. And here's +3. I have these line up. Okay. -2 line up with -2. +3 line up with +3. Okay, I'm doing that intentionally. Okay. Now, I'm going to pick a number. I pick a number from here. And I plug in x plus 2. And I plug in x minus 3. Yeah? I pick a number from here, say -7. And I plug in x plus 2, and I plug in x minus 3. I will get a negative from here. I will get negative from here. Yes? So if x plus 2 is negative and x minus 3 is negative, a negative times negative is what?
Positive.
Positive. Very good. So here you're going to get a positive. Okay, and you can keep doing what you're doing. Okay, you can plug in any number from here. You will be handling negative times negative. So they're all going to be positive. Do you follow me? Does everybody follow me? Am I too slow?
Yeah, I understand it.
Got it. Okay. So now I'm going to pick a number from here. Okay, never mind what it is. You can think of, or you can think of any number you pick from here. You can think of 0, you can think of 1, you can think of -1, any or negative 1.9, any number you pick, you are going to be doing a positive multiply a negative, yes?
Yes.
So when you multiply a positive with a negative, what is the product? What's the sign of the product? It's negative, right?
Yep. And the next one would be positive.
That's right. You got it. You got it. Okay. Does everybody get it? So now, positive. How about at -2, at 3? What happened here? If you pick -2, what happens?
Comes 0.
That's right, because 0 times anything is 0, right?
Yep.
How about at 3?
0 also.
That's right. Very good. Do you think you got the idea?
Yeah.
All right, so now I'm going to clean up. I'm going to put the sign here, okay? So if we pick any number less than -2, the product will be what? Product will be positive. At -2 is going to be 0. Between -2 and 3 is going to be what? Negative. At 3 is going to be what? At 3 is going to be what? 0, right? Beyond 3 is going to be what? Positive. We're almost done. We're almost done. I want you guys to reflect on this process. Isn't this process very simple? Is it very simple? Okay, so now let's look at what the question we have at hand. What question do we have at hand? What was the question we have? We analyzed so much, right? The question we have at hand is if the question we have at hand is if the product is negative, what could X be? Do we have the answer now? What is the answer? For all of these x's, the product is going to be positive. For all of these x's, the product is going to be positive. For -2, the product is going to be 0. For +3, the product is going to be 0. When will the product be negative? Where do you find those x's such that the product is negative? Right here, right? Do you follow me? And that is where you find the solution. Therefore, if the product is negative, the solution is what? Hold on, let me just remove that part. Okay, so if this is true, then what? Then X must be between these two numbers. And we are done. Of course, I'm going to show you a shorter version of this. This is just analyzing, figure things out. Does everybody understand? Does everybody understand this process? Yeah? So we found a solution. We found a solution. Now, Let's see how we show work. How much work do you need to show? Show work to the nerdy math teacher. How about that? Right? So you're asked to solve this inequality. Okay, solve for X. When you show your work to me, you don't need to show this much. Do you guys follow me? Now, solution. Because I teach this method, so I expect you to be able to show these work. Remove the number line. Show that piece. Then you can say solution. Oops, sorry. Solution. That's all you need to show. Okay? This is one of the methods. This is one of the methods. Does everybody follow me? This is one of the methods I wish you to know if you understand it, okay? I also understand you have learned some other techniques, other methods from your other teachers in the past. I'm not completely rejecting them. No, I'm not rejecting them. But if you feel you understand those methods you presented, I will be happy to assess it. Even though I promote my method, because I teach this method, I want to assess this method naturally. But if you happen to show other methods, which I see very often on our first written quiz, right? I show certain things in class and I look at the quiz, I saw completely different things. Okay, I will still assess your method because there's so many methods to do this. There's so many different methods to do this. Some people choose not to show the steps. Some people choose not to show the steps and just give me the answer. So I'm going to give you the rubrics of the how I give points, because I will give you a quiz on these, okay? So this piece is 2 points. I'm sorry. Should I give 2 points or 1 point? Say 2 points. Okay. This piece, let me give 1 point now. Okay, because I can always do proportional. Okay, I can always do proportional. Hold on. 1 point, 1 point. One point. The last piece, 2 points. Do you follow me? One point include the words and the graph. If you're missing the word, I will not know what you're talking about. In the past, I've seen this, okay? I've seen this. Let me show you the example I've seen in the past. Okay, just let me show you. In the past, I've seen students show me the work like this. The student did not show this part. The student did not tell me what this graph is about. If you don't tell me what the graph is about, how am I supposed to know? If you don't tell me the graph, what the graph is about, I would not know. Do you guys follow me? You have to tell the reader what your graph is about. Do you guys follow me? If you show your work like this, you only get 2 points. I refuse to understand the other ones because you didn't tell me. Is that clear? Is that clear? It sounds pretty mean, but you really didn't tell. Your graph is not clear enough. Does everybody follow me? Am I
Yeah.
pretty mean? Do you think I'm pretty reasonable to say that he didn't tell me what this graph is about? What is this stuff? Right? You only just have to write the sign of that. It's already shorthand notation. And you refuse to write those signs just to make your picture understandable for readers, and then I will have the reason to not give you that 1 point. So the lesson learned here is that you need to understand, you need to make it easy for reader to understand what you're doing. Do you follow me? Because if you don't tell me what this is, I would have no idea if that's really what you meant. So don't imagine I am a bug in your tummy. I am not. I don't know what you're thinking. Okay. Is that clear, everybody? You probably start hating me by now, huh? But it's better I said it now than later, right? Than getting a shock. So, oh, she didn't tell us. I tell you everything. I tell you everything I can think of. Okay, how I grade your work, why I take you points away, why I give you points. They're all here. They're all in my lecture. Okay, how your work is being read. Okay, with that said and done, okay, with that said and done, okay, the lesson learned is that you always have some even minimal words to explain to your reader so your reader understand what your intention. Okay, understanding your intention. Other different ways of work, I'm not going to enumerate them because as I see them, I will give you feedback on it. Okay, but right now I'm teaching this method. I promote this method because I feel that this method make you understand the simplicity of this this type of question. Okay, next I'm going to give you another perspective. Next, I'm going to give you another perspective. Okay, and I will take you guys to quadratic. I'll take you guys to quadratic. Okay, another perspective. Okay, so I'm gonna still take this one. I want to give you another perspective. Another perspective. Okay, what is the other perspective? We're still talking about function, don't we? Still talking about function. The other perspective is that you see x as input given to this rule, right? And I view this as a function. This is my function. And the output is, of course, that's the output. Okay. Next, we know that for every function, we can make a graph. So what will be the graph? How would be the graph look like? You guys have taken those algebra classes. So how does this graph look like? If you expand this, you're gonna get a quadratic function. Okay, and if you graph this quadratic function, what do we see? What do we see? This is the curve we see. And what does it mean? Okay, so I'm gonna make some adjustment about the picture. Come on. Here, okay, this is more like it. Okay, I'm just gonna adjust the, so I'm just gonna make it 7. Okay, I can make it, let's cancel. -8, doesn't make it, okay. So this is the picture. Does everybody follow me? Do you guys still remember you learned something called quadratic functions before? Anybody?
Yeah.
You have learned it, right? And this
Yeah.
is a quadratic function, and this is the curve. So what is the question about? What this if statement is about? If you make a connection between the function and input-output perspective, we want this output to be what? Negative. We want negative output. Where do you find negative outputs? Where do we find negative outputs?
Below the x-axis.
That's right. That's right. You see how simple that is? Yeah? Now, so what are those critical? There are 2 points that are very critical, right? That's where the sign changes takes place. Yes? You follow me?
Yeah.
X plus 2 has a place where sign change takes place, and x minus 3 has a place where sign changes takes place. Okay, and of course, these 2 dots should be in circle, right? These 2 dots should be in circle. So where do you see the negative output? You just told me. These are the negative outputs, and these are the positive outputs. And isn't the solution very obvious?
Yeah.
So what have we been talking about? Function, input, output. Sometimes input is given, we find output. Sometimes output is given, we find input. Is there anything else? No, it's just different way of expressing them. And the principles we use are very simple. Positive times negative is negative. Negative times negative is positive, so on and so forth. Do you guys see that? I hope you see that. At least that's what I've been focusing on. Got it? So now, how to show work in this part? Okay, if you use this method to show work, okay, there are a couple of things you need to show me. There are a couple of things you need to show me. I'll tell you. I'm going to show you how to show work. And there's 2 comments on chat. I'm sorry, I didn't see that earlier. I apologize. Baby Sana says that you still need to use them. Depends on the age. They need to face the back. Very good. Obviously, she knows a lot about the car seat thing. We can discuss that in office hour if you wish. Okay. But thank you for your contribution, babe. Okay, so you need to mark these 2 points. You need to mark these 2 points. Okay, so I'm going to show you, you're going to mark these 2 points. Okay, so these 2 points are -2, 0, and this other one is 3, 0. So you basically tell the reader, these are the places that sign changes. Okay, and you also want to mark this is a positive, this is a positive, and this is a negative. Okay, so you have the curve graph, just sketch, so you don't have to be a precise graphing, right? And then you give the solution. It's as simple as that, as simple as that. Do you want me to show you the version of solution? If you use this method, okay, you need to give the reader a holistic picture of that picture that in your head. Okay, because there's one thing you understand, there's this other thing you make people know, you tell people no, you express it in such a way the reader know you understand. Do you follow me? Especially you encounter those nerdy professors like me. All right, okay. You understand this method, you can see this method is very illustrative. Okay, this method is very illustrative. Okay, so we're giving you the perspective and how do you show the work? Right, so let's see how we show work. To your nerdy professor. Okay, solve for x. Okay. You figure out a way to get the picture. Okay, we're going to talk about this, how you get this picture. Okay, of course, it's oftentimes at your fingertips, right? It's on your calculator. And then you need to mark these 2 points. You need to mark these 2 points. Okay, so let me mark it. Are you guys taking notes? So please do. Okay, you mark these 2 points. On the graph. Oh, wrong place. Let's scoot over a little bit, please. Ah, still not very good. I'm sorry, I'm making these adjustments because I want to show you the perfect answer I want to see. Okay? And then you're gonna mark the positive sign. Right? The positive sign here. You're gonna mark some positive signs. Any way you mark it. Okay. So let me see. Let's do a 5, 10. Something like that. Okay. On the other side, positive sign. I would say -4. And positive sign. Okay. And some negative sign. See where I put it. It's at 1, 0.1, -4. Something like that. I'm going to show you a better picture. Okay. So these are positive. Basically, you mark it. And these are negative. And some people like to do this, right? If software is easier to use, you can mark it like this, make it a little interesting graph. Something like that. And these are negative. Okay. Something similar, but nice and clear. And then you go ahead and tell the reader the solution is -2 less than x less than 3. Do you follow me? So your major work is on the picture and telling the reader how to read the picture. Okay, so you need to have this circle here. You have this circle here. You're telling the reader that that's where the output is 0. That input is not a solution. This is a circle. Okay. Input 3 is not a solution. Input -2 is not a solution because their output are 0. So you need to mark these 2 points. And you need to mark some signs on each piece. And that's how you get the points. 1 point, you get 1 point here. 1 point here. 1 point there. 1 point for the positive, 1 point for the negative, and 1 point for the marking of the points. You know what I mean? I will have a similar rubrics to grade your work. Do you understand? Because for someone like me, I have to assess your work and give everybody a fair points, and they have to be comparable. I cannot give one person 10 points for this, another person 6 points for this, right? So I have similar rubrics to distribute the points. So, and think about I'm grading, 30 some students' work. And I have to have a, criteria for this step, next step, and so on and so forth. Got it? Okay, I think that was from this you can start doing the rest of 10A, basic 10A, and tomorrow we're going to start working on quadratic. Okay, so we're doing between these two back and forth. Do you have any questions? Understand, right? You guys all understand. You all understand. Okay. Any question from anybody? So please feel free to type your question now. I'm looking at the chat. Do you have any other questions? Yeah? No? Okay, you're good. So today's homework is basic 10A. Okay, you may not be able to do all of them, but try every one of them. You certainly are given all the tools and the mathematical principles and so on and so forth. I want you to come back to ask me questions. Okay, of course, if you don't ask me questions, I will still be covering some of these questions, but I want you to have a head start first. So that way you have some thinking thoughts going through that process and to better understand these, okay? And I hope I have demonstrated the simplicity for you, right? And you got the tools. We have two different perspectives, but these two different perspectives, and that's not all. There are other methods. There are other methods to this, okay? We just don't have time, or I don't want to do it yet because I don't want to confuse you. Some of you might be confused by giving you too many tools. Okay, so let's just look at these two different perspectives. I will see you guys tomorrow, if not sooner. Okay, and have a great day.
Thank you.
Thank you.